I'm Rebecca Servaites. I'm here to talk to you about our group Act 3 and how we utilize StreetLight Data to battle COVID-19 in Ohio. Our mission is the rapid development of science, technology, and research and development of autonomy for varied military platforms. Act 3 is a special operations team that was commissioned by the AFRL commander. And we're operating as a startup business model as an alternative approach to traditional AFRL research. We're developing a product called the Air Force Cognitive Engine, also known as ACE. And it's a collection of interconnected tools that will enable users to develop complex AI solutions in real time. And we've been working with the Ohio Comprehensive Monitoring Team to make predictions about COVID-19 using StreetLight data. We decided for StreetLight, we wanted to automate our data collection. And maybe you're asking, well, why automate it? Well, we did not like manually checking for new data every day to see when new StreetLight data was going to be available. We were creating multiple analysis that had pretty much the same vectors every time, and it was very time consuming to do so. The only things that were changing were like the name and the date range. And we wanted it to just automatically download these for us and store them, update our machine learning models and display those results. So we accomplished that by creating a data science pipeline with a technology called Pachyderm. And it uses Python scripts to check when new data is available on StreetLight. And then it'll submit a JSON file that has the analysis request to the StreetLight API. And then it will retrieve the completed analysis and then feed it into our models. This is a sample JSON that we would submit to the API for our analysis, and our Python script will go through and update like the analysis name field and also the date ranges. So that was all done automatically and just by our scripts, that made it really easy for collection. These are a little tricky to create, and you have to really read the API documentation. A feature that I would like to see in StreetLight is the ability to download this JSON from an analysis that you had created in the UI. I think that would be really beneficial. Okay, so this is a diagram of the data science pipeline that we created for Pachyderm. And you can see the cylinder shapes. Pachyderm is an interesting technology. Each block and the cylinder, the data store, each of those is a pipeline, and then you connect them together to make a directed acyclic graph. And it uses something called repos. It's pretty much the same as a Git repository. And it makes commits and it keeps a history of the files that you've put into it. So if we start off on the left side, we have something called the kickoff data pipeline. And what this does, it will check StreetLight once a day through the API to see if there's any new data available. If there is new data available, what will happen is it'll create that JSON that we just looked at in the previous slide with the date range and a new name. And I can't stress this enough that you must have a unique name for the analysis, or else you will get an error and your entire pipeline will collapse. So make sure you do that. And so it'll make that JSON and then it'll put that into our data repository. Now, the way Pachyderm works, when new data is put into a repository, it will kick off the next stage of the graph here. These squares, they're all Docker containers that we have running in a Kubernetes cluster. So it's really easy to run, and the scripts are inside the Docker container. So what we do with the analysis request data pipeline is that we take that JSON that we created in the kickoff data pipeline, and we submit that to StreetLight. And the file that's put into that repository is the UUID of the analysis request, which we will need to retrieve the request when it's ready. So in the analysis S3 data pipeline, this one also kind of checks the way the kickoff data pipeline does. It'll check, I think, once a day, maybe twice a day, to see if that submitted analysis is ready. And then when it is ready, we download it and then we put it into our analysis S3 data repository. And then from there, we have 2 other pipelines that will kick off that actually format this data into the format that it needs, runs it through our machine learning models, and then sends it on to like a display so we can see our results. So I'm going to talk to you now about one of the models that we're piping this data through. So the StreetLight mobility data, we had a variety of algorithms for this, and we were taking it to estimate the movement of individuals between counties or census tracts. And so one proposed indicator for modeling the spread of COVID-19 is the mobility of people. And the idea is that the higher rates of mobility, which is measured in trips between various locations, lead to more interactions between people. And that can contribute to disease spread. So additionally to the time required to progress from exposure to developing symptoms to being tested, we expect that there's going to be a lag between mobility or interaction and recording of the corresponding cases. So for this model that I'm going to be talking about, we only collected county mobility data. So for the modeling of COVID-19, a graph was constructed where each node is representing a county in the state of Ohio, and the directed edges on the graph are added to simulate the mobility of people in the state. So pairs of counties where there are many daily trips tend to have a high correlation between case rates. And additionally, it is intuitive that large amounts of travel between counties would result in the mixing of individuals and thus disease transmission between counties. Okay, and so these are some of the results that we had. One, we have a 7-day prediction for a test data sample, and in the other, the trials are comparing the Ohio graph with no edges to Ohio graph with the edges, and that's computed for mobility. That performance was better with the use of mobility data.